In this episode, sounds very posh, I need to connect this chain onto that bellows. But it needs a couple of other things. It needs a spring, that's right, so that rather than the motor jamming and stalling, it's got a little bit of give. And I thought I'd do that with some of this nice 1/2mm spring steel wire. How easy, you just wrap it around some sort of mandrel. But no, dear friends, it's not that simple. Some of the failures of big mandrel, even torque, even pulling, even twisting, even rotary, this, that, and you get that. I think this particular steel wire must be all sort of distorted and things. That's better with a smaller one, but again, why can't it just be even? It's absolutely ridiculous. There's even a smaller one, and that's dreadful. So, in the end, the two machines are having slightly different ones. There's a slightly larger one, which is nice, it's springy enough, and there's the only perfect bit that I could cut out of this long one that was about 2 meters of wire and ended up with one little bit that worked. Anyway, needs must. Now the idea is that when the pulley rotates, it pulls the chain, and then that pulls the spring, which takes up any slack and lifts the bellows, and the bellows are stopped by a nice little pull sticking out with some red braid on it. So I feel like doing a little post with some red braid on it. Here's a little post, and I've glued on an M4 dome nut, and here's some nice red braid. So I'm going to wind that nice and tightly, and again that continues with the theme of nice little bits that are red. That'll look lovely. And here we have it. Got them both strung up, so just run through it. We've got the bellows with more of a weight, so that gravity really does make it sound nice and proper. Got a rod, brass rod with some nice red fabric on it, so that it stops it opening too much, so it won't damage the bellows. We've got the spring, so that when this hits the top it doesn't break the motor because it's a jam shut. And I've also remembered why this little bit of metal's on. It's to stop it unwinding too much, because with the weight of that, with my finger, with the weight of that and the spring and stuff, without that little piece of metal there, it was unwinding too much, and then this was all going slack, which was not good. Now, you see, you can wind that up. Let's try it and see. So I'm going to run it off 2.3 volts seems to be okay. Just get everything in. There we are. Switch it on. Look at that. You can see how the purpose of everything now, and it does look really nice. I'm so pleased. Just sort of an extra little piece of mechanism and the little brass bit shining, and the wood and the chain and the spring. It's lovely, I have to say, and it plays a perfect note, so that's brilliant. And because it's being got the motor in there, it's going to be run off an Arduino. It means I can adjust that with pulse width modulation to control the speed, because with pulse width modulation, the voltage is always 5 volts, it's just how much of each cycle it's on and off for, a bit like a light dimmer. Well, I must stop doing this, because the next thing to do is all coming together beautifully. I think I'm going to put the clock dial on, because I have just realised everything else is now done. That's amazing. We've all got all the adjuster, we've got the motor, we've got the bell, everything. And the clock's ready to go in. So, let's get the clock. Here we are. We have this sprayed up. This, I made a note on the back. This one is A, and that's A, and that's A, just to keep everything together. The other one's B. It didn't really matter about the numbers. So, I'll get that sprung clipped into there, tidy up a little bit, and then get it together. And if you remember, we've got on here, we've got the 5 flickering amber LEDs that give you the weather forecast, the radio control clock movement, which is amazing, isn't it? A normally sized clock movement which receives this radio signal to keep it absolutely spot on time. My main reason for using one of these actually is because it's a bit tricky. When you've got the rest of the barometric prognosticator hanging on a wall, you don't want to have to take it all off every time the hour changes and try and fiddle around with the back of it. So hence the fact it's got that, which also works manually if you want as well. There's the decoding chip, which will be connected up to the I2C output on the Arduino. Let's get that together. Oh, and I need to, well, before I forget, I need to glue in the infrared sensor so that it knows when the hand passes, the minute hand. Right, you just wouldn't believe how much filth can get onto a piece of glass. Not filth, but dust and marks and stuff. I've hoovered it and then checked, and there's still stuff. Now I've got some window cleaner, which is more, liquid, so water-based, so it stops any static electricity, still bits of fluff and stuff. Anyway, I will keep checking, and it's always the way that if you do get a bit of fluff, it's right in the wrong, most obvious place. Mustn't grumble. I had the foresight to put a pencil mark where 12 should be. These are the clips, which is what makes it such a nice clock to use, because there's a little plastic socket and then they just hook under there. Isn't that lovely? Lovely. And another one there. And a third one around here. Somewhere. Yeah. That's it. Dun dun dun. Yay! No major bits of floof sticking out. Good. Now I can get that screwed into there. Let's try to slot on this onto that laser cut piece of plastic, and it doesn't fit because this hollow bit, if you remember, that was cut out, you find it's expanded and contracted a bit, which is okay, except this won't fit on, so I'm going to have to drill this out. But not just any drill. It's a 20mm hole saw, which actually works pretty well on a lot. And there we have it, ladies and gentlemen. 20mm turned out just to be enough to take the edges of the teeth off, and now that should slide on. That's better. Now, ready to put the clock on this one. But before I do, dun, dun, dun. It's the sort of thing you spend hours screwing it all together and then realise you have to take the whole lot of parts to get that on. And today, dear friends, we're going to fix the clock movement on with one piece of plastic, two large washers, brass of course, and a longer piece of plastic with two slots, and two more washers. Why simplify anything? There we are. And two number 8 brass screws, wood screws. Thankfully the pilot holes that I drilled all line up beautifully. Right, and again without slipping and putting a huge scratch right across everything, that means I'll have to do it all again. The tension is palpable, especially whilst working over a camera. With my lovely cotton glove I can then shove all that in and then I'll tie it. Anyway, I'll get them done. And that's what I'm talking about. One little slip with the screwdriver. Luckily I haven't screwed any of the rest on and the base is fine. I'm not going to put up with that. We can see it actually, there's a little speck anyway, so I'm going to have to respray that. Heavens to Betsy. 10-20 minutes later, because that paint does dry very quickly. Steady hands. My godfathers. Right, I'm not even going to video this, I'm just going to get on with it without any additional pressure. Dear oh dear. Right, got that stuck in place. Well, that's screwed down without any more incident. And I've got that stuck in with some, what do you got, epoxy resin. Another lovely little bit of blue tack to hold that nice and tight. while that sets, and a piece of tissue just in case some should decide to try and drip onto a lovely painted surface. Now, while that's drying, you can get on with a lamp. A lamp, you say? Lamps. It's interesting when you design something like the Barometric Prognosticator and you get it all done, you think it really does need some way of illuminating it. With some of the machines, they've got illumination within the dials themselves. And other ones like the Gregorian Scribbulator's got a similar lamp to the Barometric Prognosticator. And I think it looks really nice. It could have been a shell lamp or something, but I think simplicity, there comes a time when just simple is good. So, how do we make one? Right, here are the ingredients for said light. I've now remembered what this is for. Couldn't work out what that was for. That goes, and this is what typical case of where I knew there must be something that fitted the bill, but I hadn't got a clue what, and I wanted something reasonably priced. Now these things, these are all the wrong halves, of course. Try and find the right halves. Oh, here we are. Okay. They're wedding confetti balloon holder things. I spent ages trawling the interweb trying to find something that I could use. Plastic, a sphere, and here it is. The idea is you fill them with confetti or something else, clip them together and hang a balloon onto them with helium in it. Or in my case, you don't want the outer bit, you want this bit with a nice little internal ridge on it. That's what this plastic's for. Theoretically, it fits around there. In fact, I think I might need the other bit that was the spacer. I've probably kept the wrong bit. Anyway, it just gives it a nice little edge. I'll cut that off, obviously, and it's the perfect thing. Spray it with the normal plastic coat, metallic brass spray, and you've got yourself a beautiful little lamp. Throw in a couple of end feed plumbing fittings and some copper pipe just to support it all, and then the light source is a good quality Keys LED. It's lovely, these little things. They're from the Flux workshop in the UK. They're very reasonably priced, and as I mentioned before, they've got the heat sink on and everything else to disperse heat, and they have a little transistor there which is really useful. So you can run them with 5 volts and 0 volts, and then have the data output from a pulse width modulated output from an Arduino or Raspberry Pi or something going to the control, and then that can fade them up and down and dim them and set the brightness. And they're 3 watt maximum, which is really, really bright for this sort of thing anyway. So there's that, and then there's this rather strange looking jig. Can you work out what it's for? I'm sure you can. It's to support this while I drill the hole, because I kept shattering them, and I thought, well, it works really well. And that was wood filler. I got to the right shape just by packing it in and squeezing one on and then letting it set and then taking it off and see where the hole's going to go. That works really nicely and it stops the thing shattering. Right, enough talking. Let's get on with it. I've just found the right piece of plastic that this pushes on around here. And that's really nice because it just, when it's sprayed up, it just gives it an edge like it would have if it was made of pressed steel. Lovely. Oh, and finally, to connect this and to support it mechanically, I'm going to use some Veriboard, because I found that if you cut it just to the right width, it'll sit within a piece of 15mm copper pipe like that, insulate it. You can glue it in with super glue. It'll mechanically support it. It's made of fiberglass, so heat isn't a problem, and it holds it away from the plastic bit. So it's all nice and hunky-dory, and then you can just solder the wires onto it. So it works really well. Actually, second thought, I think I'm going to call it a day there, because we've done lots and I've talked lots, and there's probably about a video's worth. And getting on with the lamp next time will be nice and something to look forward to. Lovely. It's been a most successful day, and it is really good to see the Barometric Prognosticator coming together. I mean, that's all the mechanical parts now. Once the light's done, it's going to be a case of wiring it all up. Thanks very much for watching. Hope it's been enjoyable and hopefully inspiring you to get on and make your own amazing machines. Please click subscribe and like if you have and want to. Hope to see you next time. Thanks again.